UV index of about 300. No, it is so much worse. Thank you to everyone who commented, and especially thank you to Sean for emailing me with so much kindness. This is exactly what I would have hoped for when I get something wrong or open something uncertain up for discussion, so thank you. Here's where I went wrong. I misinterpreted this data, which described on this webpage as the absolute solar irradiance. I assumed the absolute in a similar way to absolute brightness of a star, which is the brightness of a star regardless of distance. So I mistakenly thought that that meant it was the total power output of the sun, but that number is way too low to be right. Instead, this data is the total light from the sun received above Earth's atmosphere. So let's correct this. The total light output of the sun is about 63 million watts per square meter. Yeah, on reflection, that sounds a lot more reasonable. But let's still use the 8% to account for the UV light emitted by the sun, which gives us about 5 million watts per square meter. Now, Clemens on YouTube mentioned that it's a grave mistake to ignore UV wavelengths that are shorter than 295 nanometers. And while I totally agree, I still want to stick to the method for calculating the UV index, otherwise all of this becomes meaningless. Anyway, 15% of 5 million is about 750,000 watts per square meter. Now, one part I will ignore is the weighting curve, because that, in a way, I think accounts for the atmosphere absorbing some UV light. And what isn't there next to the sun? Earth's atmosphere. So what's the maximum UV index next to the sun? About 30 million. Now that feels a lot more reasonable. Again, thanks to everyone who contributed to the discussion. This is the sort of critical thinking and care for each other's learning journey that I strive to foster on this page, and I am so glad that you've treated me with that same care. It truly makes me love this community so much more. You are all fantastic. I hope you have a great day, and I'll see you next time.